Jeremy Cook here for JC Audio, and I've made what I believe to be the world's smallest MIDI controller. It measures in at just 1 cubic inch and has 4 button inputs along with an LED to indicate signal transmission. It connects via a standard 5-pin MIDI plug and is internally powered. I'm really excited to show this off, so let's see how it was made. I designed the 1-inch MIDI in Fusion 360, minimizing each component to get it inside the designated volume. A MIDI DIN socket forms the heart of the device, straddled by 3 0.8mm PCBs. A 1.6mm thick CR2016 battery provides power, and an AT-Tiny85 microcontroller sends MIDI signals. 4 slim buttons are used as inputs, and 2.5mm screws hold everything together. They also provide board-to-board electrical connections. To test out the idea of a low-power AT-Tiny MIDI controller, I made a perf board prototype using an AT-Tiny85 chip and capacitive inputs. While the MIDI spec was originally written for 5 volts, with the proper resistors it can also work with a 3 volt CR2016 battery. From there, I designed the electronics in KiCad. It's made as a single PCB that breaks into 3 parts once populated with components. This makes assembly easier, but ensuring that all connections are properly routed is challenging. Using screws as connectors isn't exactly a standard method. I also added an auxiliary I/O connection, which could be useful for expansion later. Once the combo PCB arrived, I had to cut down the solder stencil and apply solder paste. The lead-free solder paste that I used was expired and kept in a hot environment, and I'm not even sure I got the temperature profile correct. As you'd expect, results were marginal, but after some work with a soldering iron and wick, everything eventually worked. Initial assembly went okay, but a few things didn't quite fit correctly. I had to cut the board down with snippers, grind the top of the MIDI jack, and make a 3D printed support structure for everything. There was also some Dremel tool work later to get it down to a 1-inch cube. The end result was a really tight fit, but eventually I got it into my target 1 by 1 by 1 inch volume, or 25.4 millimeters. I don't have footage of it going into the white cube, as I literally had to cut it out. Code for the 1-inch MIDI was written in the Arduino IDE. The ATtiny85 was flashed using a programmer and chip clip. The code first loads the necessary libraries. MIDI and software serial allow for communication, and TinySnore puts the ATtiny85 into a low-power sleep mode. Pins are defined as shown, with reset pin 5 used as a dummy MIDI input bit. 2 analog pins are used for the button inputs. The note input status array defines 4 on-off slots that indicate each button that is pushed, and the note status array shows which of the 4 notes is on. Finally, the note value array defines the actual key that is triggered, starting with 60 or C3, then C sharp, D, and D sharp. With these initial conditions set, the program gets the button input voltages. Each button works by triggering a voltage divider. The program compares these readings to find out which button has been pushed. After setting the note input status to 0, if the reading on Sig1 value is over 800, both buttons have been pushed. Over 700 indicates only button 1 has been pushed, and over 100 indicates only button 0 has been pushed. The same process is repeated for buttons 2 and 3 via the Sig2 value reading. The program then loops through each note input status value, and if it's true, indicating the button is pushed, and the note in question is off, indicated by note status, it sends a MIDI note on signal and blinks an LED. A similar process is done for the MIDI note off signal, and it loops through to see if a note is on and if the corresponding note is off. Importantly, it goes to sleep via the snore routine for 50 milliseconds between operations. This allows it to use a minuscule amount of power and forgo any sort of power switch. So let's see how it works. Basically, you just plug it into a MIDI to USB adapter, then plug it into your iPhone or anything else like that to create the MIDI sounds. I hope you enjoyed the build video and my mini concert at the end for what that's worth. Code and other info is available in the video description. Thanks so much for watching. This is Jeremy Cook for JC Audio, signing off.